Hello everyone, I am Professor Awais Ahmed Hussaini, working as Assistant Professor in Mechanical Engineering Department at Sharad Institute of Technology, College of Engineering, Yadram. So in this video, we will discuss Rotodynamic Air Compressor. So this is a general classification of the compressor. First is that positive displacement compressor and second one is Rotodynamic type compressor. We already studied reciprocating compressor. In that we already studied that single stage and multi-stage compressor. Also we covered the part of the rotary compressor. In that root blower compressor, vane type compressor, screw compressor are over. Now in this video we will discuss that rotodynamic air compressor, and we will study that centrifugal type compressor and axial flow type compressor. So that most important part is that rotodynamic compressor are divided into two types. The first is that centrifugal type compressor and second one is axial flow compressor. So let us start with the centrifugal compressor. So basically there are so many parts of the centrifugal air compressor. The first is casing is there. Then next important part is that inlet section. So this is the inlet section. Then impellers are there. These are the impellers. Then these are the diffusers are there. Okay, so these are the basic four parts of the centrifugal compressor. First is that casing. This is the casing. Second one is that impellers. Third one is that particular diffusers are there, and that inlet section. These are the basic four components of the centrifugal air compressor. Okay, so there is one working principle of the centrifugal air compressor. When the air is passes through the rotating impeller, it experiences force on the work which is performed by the centrifugal force. So whatever the air from the atmospheric come inside from that inlet section, then it is passes through the impeller. So this is the main important thing. The air flow, its velocity, then at that time what happen, whatever the air is passes through that impeller, the most important thing is that impeller exert a force on that air, and that particular air get speed up. So velocity and speed as well as pressure is increases, and important thing is that impeller is directly connected to the motor. Okay, when the motor rotate, impeller is rotated with a high speed. When the inlet air is passes through that inlet section, so this is the inlet section central position. From that air is continuously passes through the that particular impellers. The impeller is mounted on the motor shaft, and it exert a force on that air, and air get energized, velocity is increases, speed is increases, and the pressure is also increases. Further, that high velocity, high pressure air when enters in the diffusers, so this is a diffuser ring. So keep in mind that this is a diffuser ring, so it is continuously in static condition. When the air is passes through that diffuser section, what will happen? Yes, so definitely its velocity goes and reduces, and further pressure goes increases. And after when the air, high pressurized air from the diffuser is passes through that casing, the casing is designed in such a manner that area of the cross section is continuously increases. So here you get idea about the area's cross section continuously increases from inlet to outlet condition, and finally the air is continuously moves out through this particular delivery section with a high pressure. So this is the main working principle of the centrifugal air compressor. So I repeat once again, whatever the air from the atmospheric come inside through that inlet section, and the impeller is mounted on the blade, impeller is mounted on the shaft of the electrical motor. The impeller is rotate already with a high speed. When that atmospheric air is come in contact with the that particular impeller blade, then definitely it exert a force on it, and air velocity get increases, and the speed and pressure is also increases because of the centrifugal action. Why the name the centrifugal compressor is given? Because it create a centrifugal action. Okay, so impeller thrown away that air outside through that centrifugal force. So this is the most important thing. That's why the name is given that centrifugal compressor. Keep in mind that. And that high velocity, high pressure air when enters or when it is passes through the diffuser, where that in diffuser the velocity get reduces and pressure is increases, and high pressurized air further increases when it is passes through the increasing cross sectional area of the casing. Okay, so casing is designed in such a way that the the inlet to outlet, the area of the cross section continuously goes on increases. It will help to increase the pressure also. Okay, so generally volute type casings are generally used in case of the centrifugal air compressor. So this is the construction and working of the centrifugal compressor. So this is the cross section. So this is the suction side from where the air is continuously enters and it passes through the impeller, and from that impeller the air is continuously come in contact with that diffuser section, and from diffuser section continuously air is high pressurized air is moves out through that discharge line. So this is the basic working principle of the centrifugal compressor. So these are the some important auxiliary parts of this that particular centrifugal compressor. So in that rotor assembly, main shaft is there, impeller is there, stressed runner is there, disc spacer is there, balanced drum is there. Similar way that stationary part consists of that casing. That diffuser is nothing but that nozzle. Keep in mind that the main function of the nozzle or that diffuser is to convert that kinetic energy into pressure energy. So volute is nothing but that casing is there, bearing is there, then shaft seal are there. So that parts are divided into two types. First is rotating parts and another one is stationary parts. Okay, so this is the basic introductory part of the centrifugal compressor. Centrifugal compressor are the turbo machines employing centrifugal effects to increase the pressure of the fluid. So that's why the name is given that centrifugal. Because of that centrifugal action, the centrifugal force is created and high pressurized air will produced. In centrifugal compressor, energy is transferred by the dynamic means from the rotating impeller to the continuously flowing fluid. Again, it is most important thing. The main feature of the centrifugal compressor is that the angular momentum of the fluid flowing through the impeller is increased partly by the virtue of the impeller outside diameter being significantly larger than its inlet diameter. Okay, so this is the meaning of that particular third sentence is we are designing a casing in such a manner that the area of the cross section is continuously goes on increases from inlet to outlet in order to increase the pressure. So the last thing is that the pressure ratio of the order to 4:1 can be obtained from a single stage compressor manufactured using conventional material. So the meaning is that there are two kinds of the centrifugal compressor are there. So in case of the single stage centrifugal compressor, only one impeller is used, and in case of the multi-stage compressor, number of the impellers are to be is to be added in order to increase the pressure. So keep in mind that. So here these are some important parts once again. So this is the impeller eye. Impeller eye is nothing but the suction line through which the air is enters in the passage. So this is the eye of the impeller, you can say it as. Then it is passes through the vents, you can say it as the impeller, and finally it is passes through the diffuser section through which further pressure will increases. So the second type of the rotodynamic compressor is the axial flow compressor. So again it consists of the basic component. It consists of the one shaft drum. So that drum is continuously connected to electrical motor. When electrical motor rotates, that particular drum or that particular shaft is continuously rotate with it. So basically there are four basic parts. First is that rotating drum. So this is the first part. Second one is that stator blade. These are continuously fitted with that drum. Here you will get idea. These stator blades are continuously connected with that particular that rotating drum. Sorry, these are the rotor blades. These are the rotating elements. Okay. Third one is that stator blade. So this is a stator blade. It is continuously connected to the casing. It is static condition. There is no any kind of the moments is there. So these are the that particular static kind of the blades. There is no any moment is there. And last one is that casing is there. So this is the important thing which will helpful for that studying that axial flow compressor. Next important part is that particular inlet section, and this is the outlet section. Okay, so these are the basic parts of the axial flow compressor. I repeat once again. The most important part is that rotating drum. So this is a rotating drum. It is connected to the shaft of the electrical motor, and the rotor blades are there. Rotor blades are continuously attached to that rotating drum, and they are rotated with it, so the name is given that rotating drum. And the third important component is that particular stator blade, and stator blade is in static condition and it is always connected to the stator. There is no any kind of the movement is there. This is the fourth part, and casing is there along with that stator blade. Fifth part is that inlet section, and that sixth part is that outlet section. The design of the casing in such a manner that the area of the cross section is continuously goes on reduces in order to provide the proper pressure action. Okay, so now we will discuss how it works. So this is the main interesting question. So it is a essential and axial flow turbine, or you can say it as a compressor driven in the reverse direction, except that in order to achieve a sufficient high efficiency, it is necessary to design blades by taking extreme care. So the most important thing is that the blade design must be most important while designing that axial flow compressor. So this is the first part. So this is a rotating drum. So this is the first part of that axial flow compressor. Second one is that blades. So these are the blades which is continuously attached to the rotating drum. The third important component is that stator blade. It is connected to the casing. So this is the casing. This is the fourth part. The fifth part is that inlet section, and sixth part is that delivery section. So these are the basic parts of the axial flow compressor. So now let's start with the working of that axial flow compressor and how it works. So air from the atmosphere, means low pressure kind of the air come in contact with the frontal area. So this is the frontal area, and when it is come in contact with the number of the blades, then it is trapped in between these blades. Okay, the fixed blade and rotor blade, that air get trapped. And what will happen when that rotating drum is attached to the shaft? It is mounted on the shaft. Keep in mind that rotating drum is always fitted to the shaft, and that shaft, which shaft? The motor shaft. Okay, when that shaft rotates, the rotating drum is continuously rotated with the very high speed, and because of that rotation of that drum, the rotor blades are also continuously rotates along with it. Okay, so it also that casing is there, and the stator blade is always connected to that stator, and it is in static condition. There is no any kind of the movement. Okay, when rotating, when the shaft rotate, rotating drum rotate, and when rotating drum rotate, the rotor blades, these are the rotor blades. So this is a cross section. These are the, you can say it as a moving blade. They are also rotated along with the rotating drum, and when it rotates with a very high speed, it creates a suction on the frontal side. So this is the frontal side. So what will happen? The air come in contact with the number of the alternative arrangement of the fixed and the moving blade. So here one set of the fixed blade, one set of the moving blade, such kind of the arrangement is there, and it is the air is trapped in that particular passage. Okay, and it create a vortex action, and it create the very tremendous high pressure, and finally the high pressure is moves out when the air is continuously passing through the alternate arrangement of the fixed blade and moving blade. So how the main interesting question is that how that air gets sucked, and in which way the pressure is increases at the end. The answer is very simple. When that drum rotate along with its rotor blades, it create a suction through that frontal line, and air is come inside, and they get absorbed. And when air is trapped in the passage of the, or in between that casing and rotor and stator blade, so it exerts a force on it, and it is continuously passes through the alternative arrangement of the fixed and rotor blade, where the rotating drum is continuously rotated along with its blades, and it creates exert a force, and it exerts a force on that air, and finally high pressurized air moves out. So this is the basic construction and working of that that particular axial flow compressor. Now this is the main comparison, you can say it as, between that centrifugal and axial flow compressor. Okay, so that engine type, for if the application is that engine, then definitely the small is required, that compressor is required, and here if you prefer that axial compressor, the large engine is required. Okay, in case of the axial flow compressor. So the mass flow rate is generally in between that particular limit. and it is generally in the range of the 10 to 15 kg per second, and it is very high in case of that axial flow compressor. So the efficiency is low as compared with the axial. The efficiency is more here. So number of the stages required is small here, but the number of the stages required is more in case of the axial flow compressor. The pressure ratio per stage is in between that 5 to 7, and definitely the pressure ratio is low, so it is up to that 1.5 or below that. The pressure loss which is high for more than one stage, and it is low, thus allow using many stages. So that's why this is the main reason. So that's why we are using that axial compressor for multi-capacity, high capacity or multi-stage application as compared with the centrifugal, because the pressure losses is less in case of the axial flow compressor, and it is high in case of the centrifugal compressor. So fixing and manufacturing is easy in case of the centrifugal compressor, but it is little bit complicated in case of the axial flow compressor. The cost is cheap, and the cost is little bit expensive, and it is expensive as compared with the centrifugal compressor. So students, this video will get you the idea about how that rotodynamic compressor works. There are basically two types we already discussed. The first one is centrifugal compressor, and second one is that axial flow compressor. Thank you.